All right, here's an example. Find max min of x plus 2y plus 2z under constraint x squared plus y squared plus z squared is equal to 81. Now notice that this is a constrained optimization question. Is that right? So what do you use? Lagrange multipliers. This is in 3 variables rather than 2, but the same geometrical property holds. I mean, if you had the level surfaces of this and compared with this surface, you would know that it has they should be tangential to each other. For those two surfaces to be tangential, you need their gradients to be in the same direction. Okay, so what you do is, to solve this, you just say gradient of this thing should be parallel to the gradient of this. Just compute them. Okay? So what's the gradient of this? 1, 2, 2, right? And then gradient of x squared plus y squared plus z squared is 2x, 2y, 2z. And then you say one is parallel to the other. So I have to multiply lambda somewhere. Which one do I multiply lambda by? This one or that one? Which should I do? I want to do this one because that gives us a simpler equation. You say 2x plus 2y, 2z, 2 times lambda times 1, 2.
You multiply by 2?
Let's put 2 lambda here because that way your x and y and z will be easy to compute, right? Okay, so let's put 2 lambda. And if you solve this for x and y and z, what do you get? You get x equal to lambda, y equal to 2 lambda, z equal to 2 lambda, right? 2x equal to 2 lambda times 1. That's what you get. 2y equals to 2 lambda times 2. So 2y is equal to 4 lambda. Right? If you solve it, I think you're getting confused. Let me just write everything. I should be skipping steps. This means you have to multiply everything by 2 lambda. So it's 2 lambda, 4 lambda, 4 lambda. Then you have 2x equal to 2 lambda, 2y equals to 4 lambda, 2z equal to 4 lambda. Now notice that if we didn't have the 2 here, then I would have 2x equal to lambda, which will give us x equals lambda over 2, and we get a fraction. It's not totally impossible to calculate afterwards, but it is annoying trying to handle fractions. So this is easier. Having a 2 there is easier. Okay, so solving those, we get x equal to lambda, y equal to 2 lambda, z equal to 2 lambda. Plug those in here. We have lambda squared plus 4 lambda squared plus 4 lambda squared equal to 81. So 9 lambda squared is equal to 81. Lambda squared is 9. So lambda is plus or minus 3. So we know that the maximum and minimum of this function under this constraint happens when lambda is plus or minus 3. And then you just go back and plug these values in here, here, here to get the x, y, and z. is 3, 6, 6. This is for lambda equal to 3. For lambda equals to negative 3, we have negative 3, negative 6, negative 6. Now for this case, what's x plus 2y plus 3z equal to? No, 2z. 3 plus 12, that's 24, 27. I think it's the same thing with just negative, so it must be negative 27. And since this is greater than that one, this must be the maximum, that must be the minimum. Yes?
How come you put 4 lambda and you put lambda squared plus 4 lambda squared plus 4 lambda?
Oh, that's because we have to do y squared, right? That's 2 lambda squared. That's 4 lambda squared. I have to plug this 2 lambda in here,
Yeah.
right? If you do square of 2 lambda goes inside the square, right? 2 squared is 4, so that's equal to 4 lambda squared, isn't it? I'm doing the same thing here too. Any other questions? Yes.
Is it always gonna be
No, I just came up with easy examples that happens to be of the same pattern. This was just a demonstration that Lagrange multipliers can also be applied in three variable case. Okay? But let me show you another example, which is quite hard. Okay? But this is funny. Yes.
So is the answer 27 and negative 27 or 3, 6, 6?
No, it said find the maximum and minimum. Okay, well, I guess it depends on the question. If the question says find the maximum and minimum value of this function, what are the maximum and minimum value? 27 is the maximum and negative 27 is the minimum, right? What if the question was find the point where x and y, x plus 2y plus 2z is maximized or minimized? In that case, the answer should be this one. Depends on the question. Any other questions? I like the questions I'm getting here.
Would you take out points and just put like all the answers? So we know?
Okay.